Hi, my name is Dr. Sean Patrick McBride. I'm an associate professor in the Department of Mathematics and Physics here at Marshall University. So thank you for joining us for our talk tonight. I want to specifically thank Sydney here. She's done a fantastic job of organizing our speakers for this semester. So thank you, Sydney, for all the work you've done for the series. She's done a lot of communication there with our speakers and getting everything organized. So really any credit goes to her for help making this happen this semester. So I do appreciate that, Sydney, as well as all of our SPS members. So Sydney will talk a little bit here about what our Society of Physics Students Club is more about here in a second, but I wanted to talk a little bit about Marshall in general and our department, which the Society of Physics is tied to. So our department is a vibrant community of scholars who are passionate about exploring the fascinating intersection between mathematics and physics. In our program here, we have over 20 faculty members in the mathematics program portion of it, and we have around 8 faculty members in the physics portion of the department. So we have several graduate and undergraduate options. So the undergraduate options are BS degree in mathematics, BS degree in physics, and a BS degree in statistics. So there's also some programs in data science that are coming up as well. So we have graduate programs in mathematics, that's an MA degree. We have a physical and applied sciences, Masters of Science degree. We also have a Masters of Science in physics. So Marshall University's often been described as just the right size university. So it's not too big, it's not too small. It's just the right size university. So we have ratios of about 17 to 1 for student to faculty ratio, and there's about an average class size of about 20 students in undergraduate classes, and graduate class sizes is around 10 students. So we have around 8,300 undergraduate students, about 2,400 graduate students, and about 550 students that are in professional programs such as the PharmD and MD programs. So over 85% of our faculty have terminal degrees in their field. And that's just a little sliver of information about Marshall. If you have more questions about Marshall or our Department of Mathematics and Physics, feel free to reach out to me. And if I don't know the answers, I'll try to get you in touch with somebody that does. So my email address is mcbrides@marshall.edu. So that is MCBRIDES at marshall.edu. So I think with that, I will hand it over to Sydney to properly introduce our speaker for tonight and introduce our SPS Club.
Thank you, Dr. McBride, and thank you to everyone joining us tonight. The Society of Physics Students at Marshall University is a nationally recognized chapter. Our group is made up of students from all different major discipline backgrounds, and you do not need to be a physics major to join. We meet bi-weekly through the fall and spring semesters and do public outreach generally with surrounding area schools. Another portion of what our club does is the Faces of STEM speaker series. This speaker series originally started as the Faces of Physics speaker series, but has evolved to include diversity in speaker fields to represent our own diversity interest within the SPS group. Our goal is to highlight the work of researchers from underrepresented groups to promote inclusion and inspire the next generation of scientists to find their place in exciting STEM fields. Tonight we have joining us Alex Wriston. Alex Wriston is currently a transportation maintenance assistant in District 1 of the West Virginia Division of Highways, where he manages and develops solutions to a multitude of situations that arise daily. Prior to his work at the WVDOH, Alex spent 6 years as a high school physics teacher in the Kanawha County School District, developing a multitude of courses as well as working with extracurricular organizations that focused on STEM activities such as VEX Robotics and the West Virginia Bridge Design Contest. A graduate of Marshall University studying physics education, Alex also completed his master's work at Marshall, focusing in technology learning and education. Thanks again to all of you for coming, and a huge thanks to Alex for taking the time to talk about his work amidst his busy schedule. So without further ado, from the West Virginia Division of Highways, Alex Wriston.
Thank you, Sydney, and thank you, Sean, for having me on this evening. Going to be honest, it's been a little while since I talked in front of folks. I'm a little bit nervous, and when I hear some of my stuff said out loud like that, it's much more impressive than I give myself credit for sometimes. Um, I am a maintenance assistant in District 1 at the West Virginia Division of Highways, like she said there, and I am a former uh, student there at Marshall University. I'm a graduating son of Marshall. Uh, Sorry, I took some notes here and I can't read my own writing. Uh, Before I was that, I was a physics teacher for quite some time, and it is something that I still have a great deal of love for and passion. But I felt like I could do something else in my new position, so I had to step away from education. This evening, I wanted to talk a little bit about a concept that I noticed when I was teaching, and a lot of what I'm going to be speaking about isn't really directly research based. It's more something that I just observed over the 6 years while I was in the public school system. Uh, so this is going to be mostly perspective and experience based from me. Uh, the biggest problem that I've come across while I was still an educator is that I never found that students asked the question why enough later in their secondary and honestly their primary school time period. And what I mean by why is a lot of times when we have small children, they'll ask us why, and we explain to them simple things as quick and simply as we can to get them to move on, whether it's at the store or through functions or whatever we're doing. And I worry sometimes that we don't encourage it enough as children grow up. And especially as an educator, that was something that always bothered me, especially being a physics specific educator, because that's what we do. We answer why questions. Uh, what I have noticed with that is I think I don't want to say fault, but I will just because it's the best word possible at the moment, is that we focus a lot on the idea of not problem solving, but information gathering. We don't look for multiple solutions to figure out what we're doing. We just focus on getting from point A to point B when we're educating ourselves and other people. Uh, what we can do, hopefully, at least I think, as educators potentially and scientists and just people who like STEM in general, is take a moment and maybe we should ask why more often as well when we're dealing in those kind of situations. And that's going to keep us having a lot more of the science interests in our children's background and in the future of the folks around us. Uh, like I spoke to Sean and Cindy before this started, this isn't going to be a traditional talk. This is pretty straightforward and to the point, and I hope I'm not going to be too blunt and too short about it. I have a bad habit of being very concise in how I speak and how I do these kind of things. But I wanted to go and switch over to talking about why I switched careers away from education into my current position with the Division of Highways of all things here in West Virginia. The first thing that I looked at when I chose to do this was what is the way that I can help people the most? And hopefully, with doing that, encourage more questioning why. And what I realized was that the DOH has always been a part of my life. I have family members that have worked in it for a long, long period of time. And it's something that you do every day. You're always on the roadways, you're always on bridges, you're always doing something to transport yourself from point A to point B. And my skill set is that of problem solving. So that's what I decided it was the best option for me at the time for me and my family. Secondly, public education, sadly, from what I've seen, has shifted away from the concepts that I was speaking of before about STEM based ideals and problem solving specifically, and moved much toward a standardized assessment approach of things. What I mean is, we look at bubble sheet tests. And I have no issue with those as a teacher. I've written many multiple choice tests in my life, and they work just fine. But we're not using it as a way to truly challenge students to think outside the box. We just want to get a grade and move on, and that's just not something that uh, I personally agree with as a whole educational approach. And the last thing was for me specifically was I just like I said before, I love problem solving. I like looking at something and figuring it out. And at the DOH, I'm able to do that, especially in my current role. Maintenance assistants, what we do is we essentially manage some of our satellite organizations, what we call them, but they're satellite offices where the actual boots meet the asphalt. The guys that you see on the side of the road in the vests doing the work. I manage them, but I'm able to help them find solutions to problems, whether that is a roadway slipping, it is just a standard pothole, whether it's some of our drainage issues. It's a multitude of things on a daily basis that is pretty diverse and changes regularly. And honestly, I get kind of excited about getting to go to work anymore. It's always a surprise to get emails in the morning, honestly. Uh, like I said before, I do have family involved in it, but I've also worked with what's called the West Virginia Bridge Design Contest. Well, it has a much longer title that I can't remember offhand right this second, but it's a program that we actually worked with Marshall University for quite a few number of years on, and I think we developed into our own separate ways with it. But it's a program that I competed in when I was in high school, so it's been around for over 20 years, which is kind of sad now that I think about it out loud when I say the age. But it develops the concepts of thinking about how to build something with cost efficiency in mind, as well as just literal size efficiency and strength and understanding tensions and compressions and a lot of the things that engineers do every day, which uh, I joke with my brother and my father because they're both engineers that they are basically just practical physicists while I'm a theoretical engineer. So it's a great program and it's something I heavily support. And that's something I worked with when I was teaching as well. And multiple times I got to take students to our final and even won a state championship in it. So that was really, really a great time for a lot of the folks that I get to work with. And they're doing some pretty awesome things now. I get to keep in touch with them quite a bit. Uh, sorry, I got to turn this paper on. I hope it's not too loud. There we go. Um, so like I said before, this is much shorter for me than it is most of the other folks that are going to do this kind of thing. And I do apologize that I didn't have more robust things to talk about, but hopefully anybody watching has a lot of questions. I'm always open to answer questions. That's one of my favorite things. That's why I like teaching as much as I did. But the last thing I wanted to touch on is why folks should not just look at what I'm doing and think that the DOH is a mild option for scientists or engineers, but why it's for anybody really. And it's going to come off a little bit like a job pitch, but it's not, but it also is. And the big thing is that it is not just for engineers or people who can drive equipment. It's for anyone. We have jobs all over the place. I work with people with financial backgrounds, work with engineers. I work with people who have been in the military. I work with people who deal with property purchasing and right-of-way concepts. I work with surveyors. I've got to meet politicians in this position just because that's what we do. And it's not just something where, 20 to 30 years ago it was all those are the guys who stand on the side of the road with shovels. These are the guys who stand on the side of the road and make sure that we have the best roads in the entire country, which in my opinion we rank up there with the best. Excuse me. uh, the Division of Highways is a problem solving organization as well, so if it's something that you like to do, it's a place you can work your way up and learn a great number of skills, as well as meet a lot of interesting people and make a lot of connections that can help you in future endeavors. See, as I spoke on before, the day to day for me is very exciting because it's always solving something new. It's always figuring out a problem, and it's not always even just working on the idea of how do I fix that road or that bridge or how do I make a slip not slip anymore by putting a piling wall in or whatever. It's a matter of dealing with people as well. So I get to use my background in education to work with the psychology of my employees to make sure that I'm understanding where they come from and why they have reacted a certain way or what their concerns are. So it's just a wide variety of skills you get to use when you work at the DOH. Um, excuse me. For me, over the last almost 3 years now, it kind of reignited a spark in me of asking why, because I get to do what I've been talking about, and that's solve all these problems. Uh, Getting to have that reignition feel has been uh, it's been quite amazing in all honesty, and it's made me excited about the idea of maybe in the future going maybe even back to Marshall to get another degree and possibly in education or something of the sort, and stepping into another role where I could work with that. And that just makes me incredibly proud of what I've been able to accomplish in a very short amount of time in my position and working with the people that I do. I really enjoy what I do for a living, so it's been quite eye opening, I'll say. Um, But back to my original point about the why portion of this, uh, the biggest concern that I personally have is, and I hope a lot of people can, watch this in the future, that we don't worry as much about how to get the right answer as we worry about how we can get to the right answer thinking different ways. And that's been my biggest drive for why I enjoyed physics so much in my life. I've known I wanted to do something like this, like what I do now, and like what I did before, is teaching, since I was probably in about seventh grade. So getting to live out that concept has been very, very wonderful for me, and it's led to a lot of great moments in my careers, and I hope it leads to a lot more. Like I said before, Sean and Sydney, I do apologize again about the length of this, but I'm very concise when I speak, and I do think so. It's a bit of a curse and a blessing at the same time. It's nice for folks to read papers I write, but it's not so great when it comes to giving a bit of a longer talk. But I'm absolutely open to any questions anybody has. So at the moment,
I actually have a lot of questions because this is something that I feel passionate about too, being, you were my teacher and I understand, I know exactly what you're talking about. Because I remember when it was still West Test standardized testing in the state of West Virginia, and I remember the shift when they removed science and social studies or history, whatever it was. I remember seeing the shift in the focus towards going back to English language arts and mathematics. And we're pulling away from the arts, we're pulling away from science, we're pulling away from history, which led to a massive reconstruction in syllabuses, how we teach, what are we going to teach, what are the points, and especially at St. Albans, where was such a heavy focus on that standardized testing for especially juniors and seniors, when I felt like those could have been better developed times to talk about alternate careers besides SAT, ACT scores. So, and it was super eye-opening for me because I'm currently in electrical and computer engineering, and there was so much I did not know about science. And when I got into college, I had so much less knowledge than some of the other people there, like the balance of education quality, the education competition with people that were from Europe that were in engineering classes versus just other states, their knowledge of some of this application and my knowledge, though I was still able to, do well in these classes and learn what I needed to learn, there were people already starting off who already knew what circuits were, who already had a better hands-on understanding of engineering. And I was so focused based on that standardized testing curriculum of how do I get the right answer? How do I get the grade? That I wasn't even understanding how these concepts flow from one another to see the bigger picture of like really important stuff like project development, cost analysis and economy, um, just the bigger picture. So what can we do knowing that we're saying in standardized testing for right now, at least. We don't know what's going to happen in the future, but as of right now, what can we do to get students more interested in asking why and stop being so focused on getting the answer, getting the grade? Is there an incentive that teachers can give? Like, what can we do? Because it honestly, my whole entire learning style had to change to be successful in engineering.
well said. The phrasing you're looking for is teaching to the test, and it's one of my least favorite concepts in the world. There are very few times when teaching to a specific test is ever going to help you. And I know that you originally, when you were potentially going to be my AP Physics student, those
Mhm.
tests are one of the few sets of standardized tests that I honestly agree with, because they aren't just bubble sheet tests. They have a multiple choice section, but they also have a problem solving section, and anymore they have a practical section where you have to design your own labs, and basically instead of performing it, you basically write down what you're going to do with the lab and diagram it out. And I think that's a fantastic way to learn, and it can be utilized in a lot of different fields, not just physics. It can be used in chemistry and biology as well. As far as trying to not make, but get people to ask why more often, we need to move away from the stigma that asking questions in especially educational settings, but in general is embarrassing or it's something we should frown upon. Uh, I was talking to you guys beforehand. I have a 4-year-old, and he is right at the right age right now because he's ready to finish preschool this year. He asks why to everything. And I don't ever want to tell him because I said so outside of you need to eat your dinner. Uh, I want him to keep asking why forever. And that's how early, honestly, it has to start. Uh, Parents, when they have the opportunity to explain something the right way, need to. And if it's not them, they need to take a moment and step away and find out the answer for their kids. And as an educator or as a science communicator or anything you want to call yourself involving getting the point across, you have to be able to either find the right answer or let somebody know that you're willing to find it. When I was teaching you, because I believe the only time I actually got to work with you was in ninth grade,
Yeah.
there are some things I didn't know, and I still don't know. And
Yeah.
if I knew everything, in all honesty, as much as I do like my job, I would not have to work if I knew everything. So going out and even learning, the older I get, it's a vital tool, and showing kids that they have to learn even after they get to be a grown up is going to be something that we also reinstill. And I think when you see teachers say things like, "I don't know, but I'll look into it," or "I'll find out and I'll get back to you," and they do it, that is huge. That
Right.
is the most important thing that an educator can do because we can't be dismissive of curiosity when it's a teachable moment is what I'm going to say. It's like a teacher term, but it's true. It's a teachable moment. That's really what it is.
Yeah, I like that a lot too. I think that would be better to focus on like education that is multistructural because not everyone is good at those multiple form tests. Some people may have really great ideas for a lab, for a concept that you can't really show through answering like a question about a certain law or something like that. Is there anything you've seen? I haven't really, where my mom retired from teaching, I haven't got to see what it's looked like since 2021. Is there anything you've seen that like we can do to incentivize educators to start putting in principals and the people that lay out the block schedules and all that to put a better focus back into science? Is there anything you've seen that we could possibly be moving towards that?
Not specifically currently, but my wife is actually a second grade teacher. So I do get to see the younger end of it too. And it's not a perfect answer, and it's going to sound a lot like a blow off answer because it's a lot of the way to fix a lot of problems in any job field. But the easiest way to incentivize teachers and principals or anybody who's in the education field is fund them.
Yeah,
We need to fund science,
right.
uh, just like we need to fund arts and anything else that's not going to be standardized tests. We have to make sure that people care. And the easiest way to do that is give interesting ways to learn. And again, that's another reason why I like physics so much. I mean, you've probably seen it in a lot of your classes too. Demos in physical science related courses, they're just cooler. Like I'm not going to take away from the concept of how important it is to learn certain aspects of English and how to write and classic novels or anything of that sort, but blowing stuff up is fun. And knowing why it blows up is even more fun. And when you can do it the right way and in a safe way, and you can be like, hey, look at this thing I know, but I wonder what's going to happen next if I do this other thing, that builds on itself and it builds that scientific scaffolding and learning we want to see in any portion of education.
Thank you. I just have one more question. It's more based on the division of highways as well. Um, so you're definitely gonna be working a lot with civil engineers. Uh, what other engineering disciplines do you primarily work with, like mechanical, electrical? What are the ones that you see more often, and what are the like um here there's only like four disciplines like biomedical, electrical, computer, civil, and mechanical. Are there any outside that as well that you also work with?
Truthfully speaking, we work with a vast array of any engineering type. So when I first started, our design engineer for District 1 was actually a former mining engineer. So he worked in the private industry with coal mines. I work with civil engineers on a daily basis. I actually work with a lot of students from Marshall University over the summer in our co-op programs, which is they're just amazing because they let students get real hands-on experience working with other engineers. Even if it is something just structural they're doing, it's still really good experience that they can put on a resume for the future. And there are a lot of scholarship programs through it too, which is a really cool thing that we get to do with the universities around the state, not just Marshall, but I think we work with Bluefield State, Fairmont, West Virginia University, and West Virginia State, and WTech as well. But uh, I could easily see us working with people like chemical engineers as well. Like, a lot of folks don't realize what goes into things like asphalt. Asphalt's not just rock and tar, it's specific amounts of them. And if you don't have the right mixes in your stone and your tar, you're not going to have roads that work and they're going to fall apart. And we know that because we get to work with people in our materials areas that are chemical engineers or as chemists. So we have just a vast variety of people. We even have electrical engineers that we work with who help us with some of our traffic type stuff, as far as like putting in new lighting systems or even just the standard stoplights you're going to see around any town or any major roadway.
Thank you. I appreciate it.
Well, Sydney, do we have any comments in the chat there or questions? I'll ask one, I guess, in the meantime, or more just a discussion. So definitely don't forget your roots, where you came from in that physics education. So if there is opportunities for Bachelor of Science degrees in physics that might want to do an internship with West Virginia Department of Highways, I mean, you can always forward me that information and I can pass it forward as well for internships for our physics students here as well. And also for those outreach opportunities that you've done in the past, um, don't be afraid to reach out for engineering and College of Science if you want to sort of tackle those together. I personally am a fan of doing a lot of outreach and STEM activities with younger generation of students as well to get them interested in the STEM activities. I think that's very important. So if you have stuff that's on the radar that you need help with or want to collaborate with, don't be afraid to reach out. Going back also to the discussion of the why and just teaching to the test to get the answer. My solution to that as a physics professor is the answer is only worth a very, very small fraction of the points. Almost 90% of the points in my classes come from how the student gets from reading the problem to getting a solution that will get them to the final answer. So basically it's for the setup of the problem, showing the process, right? And there's sometimes different processes to get to the same answer. So it's not teaching. You can teach physics where you're not teaching to an exam or for a final answer. The final answer is important, but that's also just a fraction of the points. So that's my solution of how to not grade just the correct answer. But yeah, reach out to us if you need any help with any of your activities, and if I can't do it or don't know the answer, I'll put you in touch with somebody that does.
Absolutely, I appreciate that, and I agree completely. Partial credit's way more important because it shows that you know how to get there. I don't know about you, but I've fat thumbed a calculator many times
That,
solving stuff.
that
It's
is
a really
correct.
fast way to get the wrong answer and be like, oh, why? Oh,
Yeah,
I'm not able to use a calculator properly more than I
right,
cannot solve the problem.
right. Or the students would get like 95% of the problem right, and then it would just be a sign error or something at the end. So, uh, you know, showing and being able to communicate your solution to somebody through writing is very important.
Could not agree more. Absolutely. It's vital. It really is, especially in STEM based concepts.
That's right.
I do not see any questions in the live chat,
Okay.
and I don't have any more myself. So yeah.
Well, the good news about it is for those out there in virtual land and for us here, we can always share this link. It will be on our Society of Physics Facebook page. And we do have a YouTube channel, I believe, as well, with all of our other videos on it. So eventually this video will be on that channel, and you can forward this link to other people and they can also watch this later. So, and if you do have any questions for a speaker, I'm sure if you contact him, he will also provide you any answers that he can to your questions at a later time. So thank you all
As long as
for
it's
being
not where you pave my road, yes.
or where there's issues, right?
Thank you.
Well, if there's no more speakers or questions, I'd like to thank you again for showing up tonight and donating some of your time to help us understand asking why is important. And I couldn't agree with you anymore. So again, thank you for your time.
Thank you guys for having me. I really appreciate it. It's always nice to be able to give back to, the place that was able to give me, 2 degrees and a very solid education and help me get to where I am today.
Thank you.